Greetings, everyone. I'm Akond Rahman from Tennessee Tech University, and today I'll be presenting our paper at IEEE Dev 2021 titled 12 Practices for Secret Management in Infrastructure as Code. This paper was co-authored by Farhat, Lamia, Barsha from Tennessee Tech University and Patrick Morrison from IBM. Our work was partially funded by the U.S. National Science Foundation, NSF. The paper focuses on how secrets can be better managed for infrastructure as code, ISC. So I would like to start the talk by giving a brief overview of what ISC is. Imagine we have the system administrator who has to provision hundreds of AWS instances. One approach could be is to write a bash script and execute it manually for all of those 100 the AWS instances. Another approach could be the use of infrastructure as code scripts such as Ansible, Chef, and Puppet scripts, where the system administrator has to write one script and then execute it once, and that will do the provisioning of for the 100 AWS instances. There are multiple tools to implement the practice of ISC, namely Ansible, Chef, Puppet, and Terraform. Each of these has their open source and commercial versions. I would like to give an example of what an ISC script looks like. So this is an example of a Puppet script, which has dedicated syntax on how to provision a file with a certain properties, such as having a mode of 644, then having an owner of root, making sure that the file is accessible to the root users, and so on and so forth. And then there are also options to actually import a dependency using include and also execute a certain command using the command syntax. The use of ISC has yielded benefits for IT organizations. For example, Intercontinental Exchange ICE were able to reduce their provisioning time to 21 minutes. The increase of deployment frequency were improved by a factor of 1200 for ambient energy, and for NASA, the patch release time were reduced from multiple days to 1 hour. Despite these benefits, our recent research shows that we have seen a prevalence of hard-coded secrets, such as hard-coded passwords, hard-coded usernames, and hard-coded SSH keys in open source Ansible, Chef, and Puppet scripts, similar to the hard-coded password that is shown here in the presentation. So this got us motivated to understand what could be good secret management practices as advocated by existing practitioners, and bring that knowledge in to help practitioners who develop IC scripts such as Ansible, Chef, and Puppet scripts, which can be summarized using this diagram. So practitioners can inadvertently introduce hard-coded secrets into their IC script development process, but with the help of secret management practices, those hard-coded secrets can be managed and secured and stored in a secured manner, so that provisioning using those IC scripts happens easily and in a secure fashion. There are multiple tools that are available for secrets management, which is integral on how secrets management should be done for ISC. So these two examples of these tools are Puppet for Hiera, Ansible Vault for Ansible, and HashiCorp Vault that is applicable for any ISC language. So the research question that we answered in our paper is, what practices can be used for secret management in infrastructure as code scripts? To answer our research question, we apply the following methodology, where we conducted a gray literature review. So gray literature corresponds to non-peer-reviewed artifacts that are available on the internet and that are expressive of developer opinions and perceptions and so on and so forth. So we selected gray literature review because recent research shows that gray literature review also encompasses and identifies insights that are novel and also applicable for a nascent area such as ISC. So we started with a set of source strings. We applied a systematic criteria. We applied a qualitative analysis technique called open coding after filtering the artifacts that we need. And then from there, we mined a set of practices. So this brings us to our results. So from 6 source strings, we systematically filtered 600 search results using the Google search engine. We identified 38 internet artifacts, 86.8% of them were blog posts. And from there, we identified 12 practices that we're going to describe as follows. So we will First, we will list the name of the practice, and then in the parentheses, we represent the number of artifacts that mentions that practice. So for example, in the case of data organization, this practice was mentioned in 11 of 38 internet artifacts and is the most frequently mentioned practice. So this practice basically corresponds to how secret data should be organized using these secret management tools. So in the case of Puppet, developers should use Hiera. For all languages, developers should use specific directories that have where each directory stores a specific type of secret. And developers should also follow naming conventions so that it is very easily to understand. So someone who's new to the contribution, who's new to the project as a contributor, can just look at the variable names and understands that if a certain variable is used for a secret or for not. The second practice is related to Ansible Vault and is specific to Ansible Vault. So to store the passwords and to manage the passwords for Ansible Vault, practitioners recommend use of separation and also use of command line interfaces. Access control, the generic security practice was mentioned so that all types of secret data is not available to all types of contributors in the project. Prioritized encryption was mentioned, where practitioners had advocated for to prioritize what types of secrets should be encrypted and what types of secrets should not be encrypted. For example, something very sensitive as a hard-coded password or a hard-coded private SSH key might get more prioritization with respect to encryption compared to that of hard-coded generic usernames, such as username or temp user and so on and so forth. Practitioners mentioned the practice of separation. So it has two subcategories: artifact separation that is applicable for all IC languages. State separation, however, is only specific for the language Terraform, and is where practitioners advocate that Terraform states should be managed separately and maintained separately and should be kept separate from secret data. Practitioners mentioned the use of login. So this is a generic practice so that troubleshooting can be done, and also unwanted access and authorization attempts can also be diagnosed. Unsealing, the practice of unsealing is unique to the tool HashiCorp Vault, and it advocates for use of automation and the use of replication. Secret rotation, where the secret that is used to manage and get access to the secret management tools is continuously rotated so that attackers can't guess what a secret is and try to do some attacks. Practitioners also mentioned application of transport layer security and also efficient searching in the case of a Puppet Hiera so that the secret data is easily identifiable and searchable. And also the practice of speed up is mentioned for Ansible Vault, where practitioners recommend not using the default cryptographic library which is used by Ansible Vault. And one artifact, practitioner mentioned limiting the number of authentication attempts and authentication duration for better secret management. So our identifier practices, not all of them are applicable for all ISC languages. For example, password management for Ansible Vault is actually applicable for Ansible. And also we noticed that for secret search and speed up practice is respectively applicable for Puppet and Ansible. And in the case of separation, we did see that the practice of state separation is applicable for that language Terraform. So our research study has a few limitations. For example, the practices are derived from 38 internet artifacts, which is not that big of a number, so we cannot make any claims on generalizability. We also use 6 search strings, which might not be comprehensive to capture all the internet artifacts. And there might also be rater bias. So all the derived practices were derived by the first author. So the first author judgment might play a role on how these practices were identified. So we conclude our presentation by first stating the contributions of to the research community. So we have identified 12 practices to manage secrets for IC scripts. So we noticed that all of these practices are not applicable for all IC languages. Some of them are language specific, such as state separation for Terraform state. And then our paper also has a mapping where each practice is mapped to the corresponding tool and also the corresponding language. So the benefit of this particular contribution is that if a practitioner is only using Ansible and also only wants to know the secret management practices for Ansible itself, then the practitioner can look into our paper and read through the practices that we identify that are applicable for all languages, and also the practices that are applicable for a certain language, namely Ansible. So in summary, we discussed the motivation for secret management in ISE. We discussed that in our prior work, we have noticed a prevalence of hard-coded secrets in the case of Ansible and Chef scripts, as discussed in our Tosin paper, and also for Puppet scripts in the case of our ICSE paper. And then based on these evidence, we took the motivation of our systematically identified secret management practices so that developers have a better understanding on how to deal with secrets for ISE. So we conducted a gray literature review, and from that gray literature review, we identified a set of 12 practices. We noticed that most of these practices are applicable for all ISE languages, such as Ansible, Chef, and Puppet, and Terraform. And there are a few practices that are applicable for a specific language, such as state separation for Terraform states. So with that, I conclude my presentation. If you have any questions, feel free to reach out to me at rahman@tntech.edu. If you are more than welcome to look at our paper, which is available publicly online on my website. Also, feel free to reach out to me on Twitter at Rahman if you have any questions and if you want to discuss about this area in future in general. So with that, I conclude my presentation, and I wish you a happy conference and an enjoyable conference at SecDev 2021.